All right, good still morning. So my name's Sidney. I'm here to talk to you about the other side of IoT. So you get to see all the cool devices and got quite a few IoT sessions today. So really excited. We had a great one before this and got another one towards the end of the day. But I get to talk to you about all the, it's still fun, but it's a different type of fun. What happens to all this data we're collecting from the IoT devices? How do we manage this? How do we actually do solutions on a scale that we've never been able to do before? So real brief, Sidney, I'm going to put my Twitter handle. That's usually the best way to get a response from me. At the end of the presentation, I'm weird job. I write courses for Microsoft, and most of them they release for free. So it's a website, edx.org. And basically, they pay me to write courses and then tell me, go tell people to go take the courses, and it's free. So it's kind of a weird thing, but I'm not complaining. Don't tell them I complain because I want this job. But I worked with authors at Microsoft. We just released a course last summer called Architecting Azure Solutions, which is like a 400 level, okay, I'm in Azure, what do I do next? We updated that one this week. In 3 weeks, we're doing another version of our Architecting Azure course based on Gen 2, or ARM, V2 of Azure. We did some courses on XAML. So if you ever wanted to get into WPF, Xamarin development, and you don't know XAML, we did a language-focused course. We even had Anders come in. Like, I bid. I was like, I want to do the TypeScript course, because I love TypeScript. And they were like, no, we got somebody to do it. I said, I really want to do it. I really want to do it. You know, here's my bid. I'm really excited. And they're like, we got somebody from Microsoft to do it. Oh, it can't be as good as me. You know, Andres is going to do it. Nope. Rescind my offer. You know, for those who don't get the joke, he's the guy who wrote TypeScript. And they're like, he's going to do the course. I'm like, offer rescinded. I'm no longer interested in doing that course. I don't want to touch it. But we're doing other courses. We're getting ready to release an Angular 2 course next month. And we're actually working with Google on that one. So again, a lot of free content out there, and I'll reference that again as we go. And that's all for me. I'm based out of Richmond, Virginia, yada, yada, yada. Here's what we're here for. All right, so one of the interesting things, and this is a really big graphic, and I'm going to zoom in on it in a second. One of the interesting things is that we have all these devices out there. We have Raspberry Pis, we have classic IoT devices, we have newer IoT devices, all taking in information. So they're basically producing information for us. And for the purposes of this talk, I'm going to call this information events. So they're producing events. And they're producing at a scale that doesn't, like, blows your mind. So we're talking millions. I've seen customers with billions of events per minute. So try to write, anybody want to write a web API? Controller for that? A couple billion events a minute? Okay, so I don't want to do it either. I think my code's good, but eh. And so we have these events being generated, and we have to get them in. And the reality is, sometimes we have a lot of events, sometimes we have a few. I'm sorry. Sometimes we have a lot of events, sometimes we have a few. And the problem is that we have to design for that. So how do we handle burst? How do we handle when we need less instances? You can write all that code yourself, but who really wants to, right? We write code to focus on our business logic, on our business needs. And if there's a service that does something for us, we can leverage that. Then once we get that information in, that's when things get interesting. So let's walk through this real quick. And I don't have a lot of slides. This is actually, I cheated. If I say I have like 5 slides, it's because it's the same slide, but I just zoom in on the graphic. So starting here, we have all these devices. They're producing events for us. And we're collecting these events. Whether it's an API we build, some gateway service we use, or one of the services I'll introduce to you today, which is Event Hubs. We'll talk about both Event Hubs and IoT Hubs. And what they are kind of, sort of queues. Everybody hates when I say this. I said this at Ignite, a kind of, sort of queue, and I got yelled at by the product group because it's not a queue. It's not a queue. Well, it kind of works like one. Can you imagine a queue that if you pop an item out of the queue, it doesn't go away? That's what Event Hubs is. It's a queue that you just read items off of it, and you get a pointer. So like a pointer, an enumerator, an array, is just like that. Items don't disappear. They just time out. Why is that useful? Well, what if I wanted 3 different services to read from my queue? Now I could do that. I could just have 3 different pointers, one for each service, the ones to read from the queue. So we have that. We have a fancy little queue. So no matter how many events coming in, if we're getting billions of events, we're getting trillions of events, or we're just getting hundreds of events, they're all queued up. Then we can read off that queue. We can write our own code, but come on, who really wants to do that, right? We want to use some type of service to read off of that queue. Now, Stream Analytics is the one we're really going to talk about today. And with Stream Analytics, we do two things. We consume events from the queue, and we sort them. Sorting them, I'm going to really come back to this towards the end, but sorting them is really interesting because we could do scenarios like give you a dashboard now with averages of values. So you don't have the dashboard with millions of values in it. You just have an average over a minute, stuff like that. And then I could put all the raw data somewhere else. So I can duplicate this data, put it in different data sources. I can put some in SQL, I can put some in DocDB, I can put some on-prem. Who cares? It's basically a routing engine. And then the part you already do every day is we store some database engine, something, HDFS, SQL, DocDB, Mongo, whatever it may be. We store it somewhere, and then we visualize the data. Now, the visualize part is we're all great at that. I mean, it's Star Trek, the developer event, right? We're all great at visualizing data. Everybody here is master of Angular and Chart.js and can do a visualization in 5 minutes, right? That's a good skill set to have, trust me. But just in case you're a little rusty and it takes 10 minutes instead of 5 minutes, you can use services for that too. Anybody here ever used Power BI before? All right, not a lot of hands. Power BI is basically just a dashboard for data if you don't want to write all the visualization logic. If you just want people to be able to drag and drop charts like they do in Excel, Power BI is pretty interesting. All right, so I told you, not a lot of slides. I want to actually get into things. So the first thing I want to really show you is I have the Azure portal up. And I have a couple of demos up, limited network connectivity. So just in case something bombs, I have it all created demos. The first thing I want to show you is a hub. Now, there's two types of hubs, event hubs and IoT hubs. Here's the big secret. IoT hubs are just event hubs with more features. Now, event hubs is literally a dumb queue. You put stuff in, you can read it out. That's the extent of the event hub service. There's really not much else you can do with it. With IoT hubs, they introduce just a layer of management on top of that. What if you want to register devices? What if you want to deactivate devices remotely, create policies, do all this crazy advanced stuff? That's what IoT hubs is. It's just a management layer and a much better SDK. So let me show you what this SDK looks like. It's really simple. So I have a sample here. IoT hubs take about 10 to 15 minutes to create. So I'm going to create one, and then I'm going to show you the sample. So to create an IoT hub, Internet of Things, IoT Hub, and I'll call this Demo Hub Star Trek. All right. I don't know how that name was unique, but okay. Star Trek, and then I'll just create it. So I created IoT Hub, and I put in a resource group. For those who are not familiar with the new paradigm in Azure, everything's a resource. Resources are in resource groups. Resource groups give you a common life cycle for your resources. So if you create 6 resources, a SQL Database, Web, DocDB, IoT Hub, Stream Analytics Job, and you put them all in the same resource group, you can hit delete on the resource group, and it will clean everything out. It also understands dependencies. So if you have a good example, if you have a SQL Server instance in Azure and a SQL Database instance, it will delete the leaf node first. So database, then server. It understands all of that. All right, so that's going to take about 10, 15 minutes. I already have one up called Event Hub Sample. I have one rule when I present. If you can't see text on the screen, yell. It's not rude. I would never know because like high resolution monitor and all that other stuff. So I have a hub here called EH Sample Hub. And essentially, it's just a queue. So I can put events on there. As a matter of fact, while I was sitting there, I canceled the operation. It's okay. While I was sitting there talking to you, I was uploading events to it. Let me show you the API. So first off, we have a URI for the hub. So ehsamplehub.azure-devices.net. When you create the hub, that information is right here on the portal. That's your host name. Now, remember I told you IoT Hubs give you a cool thing. One of the concepts with IoT Hub is that your hub has its own concept of security, but then anytime you want to upload information to the hub, you have to create what's called a device. That device uploads information. So the SDK allows you to actually, in the SDK, create a device, do stuff like that. But when you're learning all of this, I recommend using a nice little tool called the Device Explorer. Now, this is actually available on GitHub, and for your benefit, at the end of this session, everything I'm doing today is actually in a blog post, so a step-by-step tutorial. So you can replicate everything I'm doing along with all the links. So I'll share that with you. So if you don't record a URL, so don't feel bad. You'll see that I need an IoT Hub connection string to use this tool. So I go, usually the rule in Azure is if you need some type of security information, click the key for the resource. And they have this concept of policies. You can create your own policies. You can use the current policies. You can create a policy with read permission on the hub. You can create policy with write permission. You can see that registry is the devices. So you can have a policy that can only read the amount of devices you have, one that can create devices, connect devices, service connect, which is connect to the service. So you have different permissions you can do. A really simple demo, so I'm just going to go with give me all permissions. And then we have a key and a connection string. So I'm going to copy that connection string and paste into here. Now, all it does is just sets up the settings. So the interesting thing about this Device Explorer tool is the tool itself is open source, and they're dog food in SDK. So if you ever want to learn how to use the SDK to register a device, to connect to the service, just go to the source code for the tool. Is using the same SDK you would use, the .NET SDK. So now under management, I can create devices. So I have a device here I already created called test device. But if I want to create another device, let's call it second device, I could do that. Now, I can create my own keys. They have to be base64 encoded. Or, luckily for me, it can auto-generate a key. Usually when you do the SDK, you just build your own key out. So I'm going to just copy the key they created. And I have a device called second device. And that's really it. I have a device in IoT Hub. Now I can use whatever language I want. I'm just doing .NET just because I have LinkPad open. But I can go in here. My device name is second device. My device key is right here. Whoop. Let me zoom out just a little bit. The rule still stands. If you can't see anything, let me know. All right. So the class is called device client, static method, device client.create. You pass in the URI for the hub. And the world's longest class name, new device authentication with registry symmetric key. And there's actually one in that namespace that's longer. So this is the short stuff. And you just pass in the name of the device and the key. And you now have a device client. And this device client is authenticated. It can send events. The events are super simple. You just create any type of object. So I'm just creating like an anonymous type right there. So temperature F, 30 plus. Let me make this variation a little wider. 45 plus rand.next double. So a little 15 variations. So 15 down, 15 up. All right. Actually, 0 to 15. Sorry. My math sucks. Domain origin, a hard code, because nothing's better than hard coding. JSON convert serialized object. Now I have a serialized JSON string. And then I create a new message. I do the full namespaces just because I like people to be able to see where it's coming from. So I create a message. And then client.send event async. That's really it. So not a complicated SDK, not a lot of stuff you have to learn. I'm also cheating by awaiting test.delay. So just basically run this forever is what I'm telling it to do. All right, so now I'm sending events to the Event Hub. Or, excuse me, the IoT Hub, which secret is Event Hub, so yeah, whatever. All right, so I'm sending events to this IoT Hub, and I could do interesting things with this. So I have a sample already set up for you. This is going to be the part you hate. All of the cool IoT services in Azure work better in the old portal. It used to be called the current portal, and this was the preview portal. Now it's the classic portal and the current portal. So the classic portal actually has a better interface, in my opinion. for the IoT services. And you can create stuff. So we have this IoT Hub. I can go in and create different services to consume stuff from there. I have one running now. I'm going to show you that one running, show you where the data is, then I'll create it from scratch. So I'd like to show it to you first and then create it. So I have a SA job stir track. Oh, sorry, clicked the wrong one. SA job stir track under Stream Analytics. There we go. It's currently running. It takes in the IoT Hub as an input and outputs to Power BI, and it has a query. Now, I'm going to come back to the query because I want to show you what this output looks like. And I didn't sign into Power BI. If you haven't used Power BI before, you have to use an organizational account, unless something's changed, and I haven't been told. But you have to use organizational accounts, so if you have a corporate account, something like that, that's how you log into Power BI. You can see I have a nice little graph here of the data. So you can see from about, what was that? And this is UTC time, so I want to say about a half an hour ago, I stopped sending events, and then I started sending events again. So that little spike at the end of the events, I just started sending again. Let me show you how I built this report. So you can see one, this is how you would build a report with Stream Analytics. So let's, back to our graph, we take in events, we sort them, and then we visualize them. So I showed you how to send an event to the hub. Let me show you how to sort it. So I'm going to stop this. I'm going to create a new Stream Analytics instance. We're going to call this, what's the other one called? Sample Hub. All right. So I'm going to call this Stir Track. I'm sure nobody has a Stream Analytics instance called Stir Track. So there we go. And you see down there, it has regional monitoring storage account. So they collect a lot of monitoring information with Stream Analytics because you're running queries, you're sending in events, tons of stuff. So you can actually specify which storage account all that monitoring data goes in. And I've seen people do complicated solutions such as running Hadoop over the logs. All right, so we created the Stream Analytics job known as Stir Track. That's going to take about, there we go. That was fast. So the way Stream Analytics works is like, it's weird. It's not a black box. It's like a transparent box. You have an input, one or more inputs coming in, a query to sort the data, and one or more outputs going out. The syntax is really similar to SQL. So for inputs, if I want to input some data, I think the data I'm sending here is to Sample Hub. So I say add an input. And there's two types of inputs you can have in Stream Analytics. There's data stream, which is streaming data, and reference data. Reference data is if you, let's say you have some server logs from 2 years ago, and you want to run them through Stream Analytics and store some of them in SQL, store some of them in Power BI, you want to visualize them, you can actually visualize reference data. So you can do that. Basically, I like to call it stale data, but you can do that. Data stream, there's a lot of different ways you can stream data in. Lots of different ways, right? So Event Hub, IoT Hubs to talk to you about. How is a blob storage in Azure live streaming data? This is really interesting. There's a pattern that developed, and I blame Hadoop and HDFS, which I actually use it, so it's not a bad thing. But you can actually make folders for dates. So you can make a folder for 2016, make a folder for May 05, make a folder for 06, make a folder for the hour, and make a folder for the minute, and then put data in there. And it'll treat it like a live stream of data. Really weird, but you can do that. And this is more so connecting with existing systems that are sending data over. I've used blob storage a couple times with legacy IoT systems, where that's how they were storing data and sending data, or storing it in a file share like that, and I was replicating a file share. So I'm going to select IoT Hub, and I'm going to zoom out just a little bit. And we can call it whatever we want. So I'm going to call it Hub Input. I'm going to use the IoT Hub for my current subscription, so Sample Hub. Actually, you know what? I think my new hub, the demo hub that we created at the beginning, is ready. It's showing up in the list. Let's see. All right, yeah, it's ready. So actually, I have a new hub, yeah. That usually takes a lot longer, so my apologies. And you know what? I want to make this demo completely fresh, so I'm going to go ahead and stop this and start uploading my events to the new hub, the newer, cooler hub. So just like we did before, I copy the hub URI. I go in here, grab a connection string. I go in and I forgot, I'm supposed to click here. I connect to this new hub, Demo Hub Star Trek. Notice that now that I connected to this new hub, I don't have any devices, so I'll create a device. My first device. I'll copy the key. Remember, you create the keys. They don't create the keys. All the SDK is doing, or all this app is doing, is creating a random key and then sending the key to the service. So when you create a device, you can specify a key when you create the device. It says my device is now created. So I'll go in here, my first device. And I want a lot of variation here. So floor 35, up to 40 degrees of variation, and then run this. So you see right away it's sending events to my IoT Hub. So same thing we did earlier. I go in here, I have my Demo Hub Star Trek, shared access policy. I'm not going to go too deep into consumer group, but just for those who are interested, consumer group allows you the opportunity to create a different set of pointers. Remember earlier I said the interesting thing about this queue is you can have different people consuming from it. Well, the way you do that is you create consumer groups. So the consumer group is basically just a pointer, pointing to not an index, but a point in time in this string. So you can have this default consumer group start, and I can stop it for 5 minutes, and I can start that consumer reading using that consumer group again, and I can start from that pointer. And the pointer is a point in time. So any events since then are now going to come through. That becomes really important in a second when we do stream analytics. So we hit next, and we hit complete, and we now have an input. Stream analytics, what it does automatically is when you create an input, it tests the input to make sure you didn't fat finger it. For output, a lot more options for output. So you can just put it wherever you want, really. And the idea here is that I'm going to do a really simple output to demo this. Power BI. Hit next. If you're a Power BI user, it's going to try to authenticate you. Don't you love logging in this stuff? If you have more than 3 live accounts, Azure is the bane of your existence as far as logging in. All right, so BI output. We can call the data set sample data set, and sample table for the table. And I'll just put it in the same workspace. All right, so now I have input for IoT Hub, output to Power BI. Remember, I can create multiples here. And we will look at that in a second. The query is where things get interesting. So think of it like this. You got an input bringing data in a live stream. You have a query that understands live streams, that gives you a SQL-like syntax, but for live data. Now, this query decides where data goes. So you can, just like the SQL, you can have 2 select statements, and just each one selects into a different output. You can have different inputs, so you can select multiple from and do a union. You can do all sorts of crazy stuff. Well, I'm not going to call it crazy, but fun stuff. So the easiest way to do this is from your input alias, which I believe was hub input, your output alias, which is BI output, and then you could just do a straight raw copy, which is select all. But that's no fun. What we want to do is we want to create something called a hot path. What is a hot path? This is my favorite example I like to give. Soccer stadium. I'm collecting decibel information from the crowd because I want to discern patterns. Eventually, I want to feed this to machine learning. I want to do some predictive analytics. I want to learn from the noise level of the audience how likely they are to buy beer. And if you're laughing on the inside, this is actually a real-world case study. How likely are they to buy beer based on noise level, where they're sitting, and the point in time in the game? So we're going to do Hadoop and do all that fun stuff and do this. But during the game, I want a dashboard of this. So no, I do not want somebody sitting in front of an Excel file with 100 million records trying to guess what the decibel levels are. I want to give them aggregated information. I want to give them averages. The average decibel level over a minute for their audience section. Maybe I want to do the min, max, things like that. These are aggregates, just like in SQL. The only thing is, in stream analytics, aggregates are the only thing to keep your sanity. Because remember, millions, billions of events. If you don't have aggregates, you're going to have millions and billions of events on your front end. So I want to give people a dashboard, let people see some high-level information that's useful to them now, and then I can take the raw data and put it somewhere else. So how do I do that? Well, first I build the dashboard, and we call this dashboard the hot path. So I'm going to start here, and if I remember from the data is still being uploaded, I have 3 fields, temperature underscore F, domain and origin. Now let's just imagine domain and origin of fields that are different for each device and so on and so forth. So I can go in here and I can, sorry, forgot which one. I can do a group by statement, just like SQL. And I'm going to do that so you can see it. Group by. Everybody can see group by, right? In the back? All right. Group by, domain, origin. Now it's going to complain. Because just like in SQL, once you start doing grouping, you can't, select every field. So I can select domain, I can select origin, but I can't select temperature F. Now, that's because it's an aggregate now. When I have a group of records, there's multiple temperature F values. So now I have to use aggregate functions, just like in SQL. So if I want to do average, AVG. If I want to give it a nice name, I could say average temp F. I could do min. I can't spell today. I would never win the world typing competition. That's for sure. All right. And max. Oh, man. Thank you. All right. So I can aggregate this. I can say average, min, and max. But I got one problem. This is a live stream of data. How does it know when to stop aggregating? Does it just wait until the end of time and then give me the average? I have to give it windows of time. Now, anybody here can't sleep at night? Anybody have a hard time sleeping at night? There is documentation on what we call windows of time in Azure Stream Analytics. And the documentation is about as in-depth of anything I've ever read. And anytime I have a hard time sleeping, or I want to put the baby to sleep, I read the documentation. So I'm going to cheat and just use one. Then I'm going to go back and draw and explain how they work. So the first window I'm going to introduce you to is called a tumbling window. So you create a tumbling window, and then you specify how long you want this window to be. So for this example, I'm going to take a tumbling window of 5 seconds. Or, of course, I have a cheat sheet just in case I mistype something. Oh, second. All right. What does this say? It says group on domain and origin, but also group by 5 seconds. So when I'm taking this live data in, chunk it into 5-second chunks. So every 5 seconds, that's a group. And now, for each domain, origin, and 5-second window, I have a unique entry. So now I have some aggregate information. I have average temperature for each individual sensor over every 5 seconds. That may sound like, oh, well, that's a really short window. But if you have a device uploading maybe 5 events a second, that window is pretty useful. So one of the things you see here, they have a nice little button lit up called test. Everything done in Stream Analytics is done in JSON. So if you have a JSON representation of your data, you can just test it real quick. So I can go to jsongenerator.com, and I already have one laid out that nobody can see. There we go. And all I say is create a couple records, domain, Katoso, origin, ECUS, and then just throw in any integer between 1 and 20. Generate it, and it creates my nice little JSON array. I can copy that and save it. So notepad, best sample data.json. And I can go here and test it. Ooh, sorry. I called that best sample data.json. All right. If I run that, it's basically going to treat that JSON array as live data. And the timestamp for all that data coming in is right now. So right now is within 5 seconds. It's going to tumble that into a single window with a max, min, and average. Now, I can modify the timestamp. If you had another 3 hours, we could talk about that. But you can actually manage timestamps. So you can go in and say, I don't trust the timestamp that they're using. Right now, the timestamp is based on when the data is uploaded into your hub. Now, since I uploaded that array as a single file, the timestamp for every record in that array is right now. However, what if that's not useful? Let me give you an example. We have a trucking company, and they truck coal trucks, right? And we collect sensor data because we want to be able to predict not only when it's failed, but the patterns leading up to failure. One of the weird things we found was that usually the temperature spikes a little colder before the trucks fail outright. The only reason we was able to find that is because we were tracking this information long term. And what we did is we went back in retrospective, looked at the data for all the trucks that failed within the last 6 months, and sure enough, they were, I forgot what the app, but they were dipping 10 degrees colder about a week before they failed outright on the road. And so when we see that dip now, we bring it in for preventative service and was able to save a whole bunch of trucks for dying on the road with food inside of them. So stuff like that is really interesting to us. And in a scenario like this, though, we had a problem. See, these trucks are on the road. Do we get 4G everywhere? Of course not. Sometimes we don't even get 1G. And so we have to batch and upload when we have a network connection. But then that leads to an issue because the timestamp is wrong. When it recorded the reading is different from when it uploaded it. So again, we don't have 3 hours to go over this, but in Stream Analytics, you can actually say so-and-so field as timestamp. So you can, if I remember correctly, timestamp by and specify a field there. So if you upload a field with time information in it, it'll tell Stream Analytics use that as the time field, as opposed to its actual recording of the event. You'll see that in a demo in a second. All right. So far, so good. We got everything going. If you wanted to, you can actually just copy this whole statement and paste another one. And then instead of into BI output, you can put it somewhere else. You can put it in SQL. You can put it in blob storage. You can put all sorts of information. But for this simple demo, we're just going to take this information and store it in Power BI. So I'm going to save it. And then I'm going to run it. Now, when I start the Stream Analytics job, it's for that IoT Hub input. It's going to use that consumer group. Remember that consumer group I told you is a pointer based on time. So it says, where should I start? Do you want to give me a time for the pointer? Or do I start when the job starts? They'll use that time as the pointer. So you can actually go in and say, start the pointer at tomorrow. You can go in and say, start it at 3 weeks ago. Because remember, the pointer in this queue of where you're at is just a time. Everything in the queue has a timestamp, and instead of having an index, it just has a time pointer. A little weird concept to digest, but once you get used to it, you're like, oh yeah, I can't remember ever going back to numeric indexes. All right, so we're starting a job now. It doesn't take it says can take several minutes. It's been pretty fast. I'm gonna give it about a minute before I switch over to my demos already created. But essentially what it's doing here is it's starting the job. So now it's going to start taking in events from my IoT Hub, applying that query we just had to there. I can put where clauses in there. I can change fields. I can do all sorts of crazy things. Oh, man, I didn't stay signed into Power BI. Oh, there we go. I can go here, and if I look, doesn't look like it's quite there yet. Or, yeah, it's not there just yet. Let me go check the status of this. It's still starting. Once it's started up, we can actually go in and see our data set, and I'll show you how we create a visualization. Now, what I have on my blog is an example that's way more complicated, and I've already deployed it because it takes about 20 minutes to deploy. And I've already deployed it for you because I don't want you to sit here and watch me deploy this for 20 minutes. On the blog, I'll show you it real quick. Under deploying a full stack IoT proof of concept in Azure, I actually walk you through how to deploy this. So we deploy an ARM template, and then I walk through the solution. So this solution is a little weird. I have a web job that sends information to an event hub. So I don't use IoT hubs in this demo. That way you see both of them. Then the IoT hub is the input for stream analytics. Because I was bored, I put data in table storage. I never used it. But I just put in data in there. And then I also put data in DocDB, which is a JSON, JavaScript native NoSQL database in Azure. Then I create a search indexer on that DocDB database. Because I'm a true believer that you should never implement search against your primary database. You should use a search engine like Solr, indexer like Lucene, something. Please, if I go on another consulting project and I see somebody has a SQL statement for their search, I'm going to pull my hair out. Relational databases are terrible for search. That's all that needs to be said on it. So we have great search engines, some of them free, open source. You don't have to use the Microsoft ones. Matter of fact, I used Solr forever. And I'm an Azure MVP, and I'll tell you I like Solr better than I like Azure Search. That's crazy. It's just so many options out there. And then all I do is I created a website that just reads the data from the search engine. So I'm never touching the original source of data. I'm just looking at indexed information. So let me walk you through this sample. So I already deployed this. I followed what I did was in the speaker room, I went through the lab and the blog post instructions like anybody else would, and I created this. So let me show you this step by step. Ta-da! Okay, all right. So it's loaded up. The first thing that was really interesting here is that I created a service bus namespace, which is down here. What I do with my templates, I give them really random names. That's a philosophical thing that we really don't want to go into. But I'm a true believer in giving everything a random generic name and using other services such as DNS, things like that, to actually give the true name. If you rely on a name for your service, you're going to catch yourself in deployment and DevOps later. It's going to be a pain. All right. So I have an event hub here called Temp Hub, Temperature Hub, not Temp Hub, as I'm going to delete it. Terrible name. It retains messages for 1 day. So when we go through here, we read messages from the hub. Remember, we're not deleting the messages. We're just reading them using a pointer. We can always reset the pointer. We can skip the pointer. In the SDK, you can actually manipulate the pointer if you want. Please don't do it and then ask for help because that stuff's way too complicated for me. But if you use the pointer normally, I'd be able to help you. But you can retain messages for X amount of days. You can do whatever you want there. You can partition it. So it comes with 4 partitions by default when you create one, but you can change that if you want. This is really interesting because if you try to read from an Event Hub, you're gonna have a wonderful time because you have to read from each of the partitions individually and then come up with the time-based indexer yourself. And there's code out there for that. If you really want to go after it, go for it. Most people just use IoT Hub because they manage that for you. But that's actually, all right, thank you. That's how it works behind the scenes. They actually have different partitions and go into each partition and figuring out where we are in the time-based index. So this Event Hub feeds into, I can never remember these logos, a stream analytics job with an equally weird name. I think it's STSA. For the input, I have that Event Hub. For the output, I have that table storage account we talked about earlier, plus DocDB. This query is a whole lot more complicated. So instead of trying to show it to you in a browser, I have Atom open. I'll show it to you here. I promise, it looks crazy hard, but it's not that bad once you digest it. So the first thing I do down here is select all into just another identifier. So I select everything from I select the result of all records into DocDB output and select the result of all records into table store output. So up here, I create all records. So with all records as. So it's kind of a little weird SQL stuff, but no worries. So notice I have the tumbling window here, group every 5 seconds. I take the ID of the sensor and the type of sensor. I really should have made that field sensor type, but I didn't, hindsight 2020, and I concatenate them. So I make an identifier that's the type of sensor dash the name. Then up here, concatenate again. That's going to be the sensor field. Average, max, min, just like we expected earlier. I'll also get the amount of readings within that 5 seconds. Notice these weird ones, concat, date name, date name, date name. This is called buckets. It's kind of a weird thing you see people do in NoSQL databases. So instead of searching on a time, I create a day bucket, an hour bucket, and a minute bucket. So a day bucket may be May 6th. So every record that's created on May 6th is going to have a day bucket field, and then a day bucket field is May 6th. Every record that's created at 1 o'clock, or between 1 p.m. and 1:59 p.m. on May 6th is going to have the hour bucket of 13, military time. All right. So the idea here is that now, if I want to get all the records for 1 p.m. on May 6th, I can just search for the hour bucket. Let me show you these buckets look like. Remember I said it was a web app I deployed? So all this data is dumped out DocDB, so on and so forth. And this is the example in the blog. You're going to be able to reproduce this yourself. And it takes about 20 minutes. And it will deploy this nice little Angular website. And let me show you the time buckets look like. So these are all the records that have been put up in there. I started today in the speaker lounge. So the day is the 127th day of 2016. That's my day bucket, excuse me. So if I had records from other days, I would have different values in there. So now, instead of having to try to search on the time, I can just, if I know what the time is that I'm looking for, I can just build a string out of it. It's a whole lot faster, a whole lot more efficient. I did this around 8:58. So I have a couple of them for this is UTC time, so the 12th hour. And I do a dynamic filter here, the table's getting shorter. And then around 10 a.m., I believe it was the 13th hour. The minute bucket is just what minute we're at within that hour. So the 22nd minute of the 13th hour, the 127th day of 2016. So this gives me a very efficient way to search for stuff on dates and times. Remember, I put all this in a search engine, so that's even more efficient. So I'm just efficiency all out of my ears right now. And so now I got everything at and this is 5-second windows, at the 40th second window from 40 to 45, at the 22nd minute of the 13th hour, so on and so forth. So that's one way you can actually do time if you got if searching on a date time field is inefficient. I also do, and all of this is in the code, so you can go play with it, make it better if you want. Please, I have Boxplot demos. So for the 9:45, I believe, I created a chart based on I have 4 sensors, so B, C, D, and E. Actually, I think I have 5 sensors. And in my sample data, and I'm able to build a little box plot here. So there we go. I don't know why E, there we go. So I could build visualizations. This is all just using Chart.js. This is using Angular. All of this is open code. I can build a search page where I can get the average temperature and filter on range. Let's see. Let me make this a much smaller so you can. So I got 46 results where the average temperature is between 51 and 53. So the visualization part is the easy part because we're all developers. We can build as many visualizations as we want, however we want. That's the fun and easy part. If you don't even want to build the visualizations, we can go to Power BI. So remember earlier we just created that Stream Analytics instance. It's running in Power BI. For refresh, I should have a new data set called, I don't know what that data set's called. I do this all the time. Sample data set. So if I go to Power BI, I have sample data set. Within sample data set, I have sample data. And if I wanted to build a visualization, I could go in here and I can say, all right, I want a line graph. I want the average temperature, max and min on here. Let me say average temperature is the average. Max is the maximum. Min is the minimum. And then I can make time that x-axis. So I can drag it. I can't drag, so let's do that. And you can see that chart I built earlier. So we can build charts out of this dynamic data that's coming in real time. And with Power BI, you can actually, if you have a dashboard in Power BI, you can actually look at that data in real time. So this is an experiment I always encourage. There is a website, even if I'm not that interesting, I'm always going to point at you other websites, thinglabs.io. And what they do is they go around, they do Azure tours, they build labs here. And one of the labs is the Nodejs connected weather station. Now, all this does is run a Node.js application on your local machine that reads weather from a weather shield on an Arduino Uno. They recommend a SparkFun board, but whatever, it's fine. And even if you don't have the board, you can just fake it. Random number generator, just like I did, right? And it actually walks you through the process of setting up Power BI, sending telemetry to IOT Hub. So exactly everything I showed you with the Power BI side. And I always recommend to people, even if you have a real life board, this is going to sound really weird, but the best way to visualize this is have it collect temperature and then put it in a chair and sit on it. Seriously, I'm not kidding at all. I used to do this in user group talks all the time until I broke it. But sit lightly and gently on it. And then after about 15 seconds, you'll see the Power BI dashboard update with the newest temperature. So that's a great way to do it. Real quick, I just want to point you, always want to leave you with more resources than you started. So I showed you the blog post. This is how to deploy that website I showed you in Angular that takes in data from Event Hub, puts in DocDB. I made this example as complex and many moving pieces as possible so you can, as a developer, pick apart these pieces. And specifically, I could have wrote a template that auto-deployed it for you, but that'd be no fun. So I actually wrote the lab where you actually deploy everything manually. You fork the repo from GitHub. You go change the config files. This is the last thing I'll show you, the repo, and then I'll point you to other resources. The repo, it's a link in here, but essentially it's EHSA validation. All right. All this is linked, so you don't have to memorize these URLs. So this is the repo. And what I'm doing is I'm using continuous deployment to deploy this to a web app in Azure, right? Here's a little secret that not a lot of people know. You can deploy web jobs using GitHub too. The way you do that is you put them in a folder because all of this is going to be put in a folder on the actual app instance. So app data / jobs, the type of job, scheduled, triggered, continuous, and then the name of the job. It could be Node.js, it could be .NET, it could be a shell script if you want. Here I just built a Node.js job, and all it does, it emulates a device. So it emulates a device. It creates, I do everything manually on purpose. This is the hardest possible way you can do it, just so you have the source code and you can play around with it. But JSON.stringify, notice that right there, sensor ID, value, and then I just send it. So all I'm doing is emulating a device here. So when you do this demo, you don't have to have an IoT device. You just run the web job. And the instructions will tell you, go run the web job. And the web job will just pretend to be a device and send a whole bunch of messages for you. And all of this is done in config files. So you can configure it. You can take this code, make it your own, go off, have fun with it. The other thing I wanted to point you to is if you're interested in more on the Azure side, we're putting some courses out there on edx.org. Microsoft's a partner on edx, or edx. But when I say edx, people are like, how do you spell it? So I now say edx.org. We have a lot of courses out here, but we're putting more courses around data science and machine learning. So we have a Power BI course that's pretty good. Data science machine learning is one of our most popular courses. All of this is free. It's in MOOC format. So if you're ever taking a distance education course or a college course online, same format. You have a professor, you have forums, you yell at people because they don't respond to you fast enough, and you have homework assignments, and you have TAs. I didn't get a TA, though, when I did Intro to HTML5. I had 35,000 students. And I was like, I can handle this. And I didn't budget for a TA. And yeah, I spent 80-hour weeks answering forum posts, and I had to subcontract to actually do my day-to-day work so I can finish answering forum posts. And I'm still not caught up. It's been 4 weeks. I'm still working through 35,000 students worth of forum posts. All right, so wrapping things up. I try to do a demo-heavy session instead of a lot of slides, just try to show you how this stuff really works underneath the hood. I showed you my blog. It's c#run.net. That has the that's the demo I did here. So you can replicate that if you want. I answer questions on Twitter all the time. This is a really cool, interesting thing to get into. Notice the first slide I had was Lambda Architecture. This is the beginnings of you learning about and using Lambda Architecture in your applications. Lambda Architecture is all about that hot path and cold path. Some data we need right now, aggregates of information, subsets of information that are relative to us right now, and some data we need for later, cold storage. If you server logs, you might need aggregates of that information now. For long-term usage, you might put the raw server log somewhere. That's cold path data. So this hot path, cold path, this is just the introduction to it. When you start dealing with data at this scale, you're going to have to split data up and use tools like stream analytics or the equivalents for different other systems. The idea here, though, is that it's a whole new way of thinking. It's really interesting, and it doesn't just have to be used for IoT. I just wrapped up a project where we use stream analytics, event hubs, Power BI, and DocDB with, you guessed it, an ASP.NET Trace Listener over a web farm and an application with a couple million users. Their tracing logging solution, they wanted to go to the next level with it. So they actually have a logging dashboard. We call it Big Brother. And they built this logging dashboard using Power BI. So real time, the ops team can go into Power BI and see a live dashboard of perf information. And they have services to do this, but they had some custom needs that weren't captured by these third-party services. They built it raw themselves using the same steps I showed you here. So thank y'all. Might be a little boring, but data always is. And any questions you have, Twitter is the best way to get to me. Matter of fact, somebody just tweeted me when I first started talking, asking me how to replicate data between VMs and Azure. So there you go. I'm here for lunch, so if you want to see some other stuff, I haven't deleted any of the demos. So